Cracking on with the program, we have Spencer Kimball. He's our CEO and co-founder. He'll be speaking with Niemi, enterprise architect at Kindred. Kindred's been a longtime partner of Cockroach Labs. We've been in conversation with them since 2015 when we were alpha. They were design partner on geo-partitioning, which was a feature that Nate demoed for you and I think probably talked quite a lot about now. So without further ado.
Thank you, Jessica. So I think that most people in this room might not be that familiar with Kindred as a company. So maybe you could give us a brief introduction about what Kindred does and about what you do at Kindred.
Sure, Spencer. My name, as Jessica said, is Niemi. I work as an architect at Kindred Group. Kindred actually started as a company with a different name in the beginning, in the end of 90s, called Unibet. And it started as an online system to do online sports betting. And from there on grew to become one of the actual world leaders, online gaming companies, offering different types of games in a coherent platform. Games such as sports betting, as I mentioned, horse racing, online casinos, poker games, and so on. So Kindred basically offers an infrastructure and a platform to host 11 different brands worldwide. We are roughly 1,400 employees in 50 different nationalities across, I think, 10, 11 countries worldwide. And we operate mainly from one of our production sites in Europe today.
So, as Jessica mentioned, we first were introduced through your CTO in 2015 when Cockroach was just an alpha product, actually. Very few people knew about us then. How did you find out about us and what sparked your interest?
Well, back in 2014-15, we actually were in the midst of a pre-study where we looked into how we could improve our technical platform's ability to scale horizontally and globally to kind of breach out of the barriers of a single data center. We wanted to address or find a better solution for disaster recovery, to aim for something that's more about disaster resilience, where we can basically enable our system to survive a complete data center outage without losing forward progress. We also have this far distant customer markets in Australia, which obviously is very far away from Europe. So those customers are suffering from the high cross-link latencies. So as a global online gaming operator, we want to provide the best customer experience for all our markets. So to fundamentally address the latency issues that we are having with markets very far away, we basically want to move our processing units and data closer to where the customer user agents are located. So it's more about providing local performance while still be able to offer the same type of service globally. So in summary, we looked into how we can improve our availability of our platform, performance, without compromising the correctness and consistency in our systems. We also want to reduce the huge investments put into the platform today. So in this pre-study, we looked into different alternatives when it came to databases and how to manage state, because we saw earlier that it was fundamentally a data problem that needed a solid solution that were fit for purpose. And we found it through a lot of research, going through all kind of papers from Google and looking at Google Spanner, which ultimately led us to CockroachDB. So it was some speed talk that you made in CoreOS in San Francisco, I think, that I stumbled over, and then I emailed our CTO and said this is something we should check out. And from there on, it kind of grew into this partnership.
Great. I didn't actually know that story myself, so it's pretty interesting. Were there any other changes to the industry, your industry in particular, that made these kinds of changes around resilience of the data and more of a global footprint necessary for competitive edge?
In our industry, we operate in a highly regulated market, so we need the ability to sometimes, for certain jurisdictions, constrain even where that data is located within country boundaries. So from a regulatory point of view, there are kind of no compromises. We need to be compliant for the licenses that we are operating in. And if we operate from our platform in Australia, for instance, we need to comply to the local regulations there. In the same way as we do in Europe, where GDPR is highly relevant today. GDPR basically constrains the system not to expose customer data outside of the European boundaries. Same if we would enter some market in the US or South America or anywhere else in the world, we need to be able to adapt our platform easily to the local conditions and regulations. So, and all this flexibility really creates a certain level of complexity in the system that we need to manage and contain.
Great. So what will CockroachDB be used for at Kindred in the near term, and how do you see that expanding?
Well, we see CockroachDB as a key enabler for us to provide a true global service. CockroachDB offers quite very unique enterprise-level features, as we say, that was mentioned before, like the geo-partitioning feature, that by sort of enabling us to domicile customer data to specific regions, that is a really key enabler for us to be regulatory compliant, while also offering local performance, local read and write latencies. We still have customer journeys within our system that still need some kind of global control plane, such as when a customer registers into our systems, we might need to enforce certain global constraints. So we envision that we have data centers that are active in many different geographies, that they are all logically interconnected as a single cluster, as a single platform, instead of being forced into thinking in terms of segregating up the system and deploying silos. Because as part of our business scalability, we need to keep also our operational costs down while we are scaling out at the same time. And CockroachDB is a key, important enabler for this capability.
So I'm going to move back a little bit to the question I asked you before. I mentioned that we first started talking to Kindred was Unibet then in 2015, and we've grown together. Actually, you guys have provided huge help to us as a development partner. But when I look at it from your perspective, I'm still surprised that you, as a company, a very mature public company, were willing to take a bet on a relatively new startup like Cockroach Labs. What gave you the confidence to take that risk and to place a bet on us?
Yeah, good question. I mean, we strive to innovate. We are an innovative company, and we have tried before different attempts to find kind of solid failover-based, disaster recovery-based solutions. So we have gained some experience from, I would say, less successful attempts in the past, and realized in our pre-study that when we want to gain these business capabilities, we really need to address it from the core. We need to find a solution that's designed really from the ground up to support our use cases. So that was kind of the key driver, that we want to address these problems in the best possible way. So we allowed ourselves to do pretty long pre-studies to really gather all the information we want. We looked at how other companies usually do it, even Google, how they provide or operate multiple data centers across different regions in the world. And we basically did our homework, and we learned from the past, and we are not really afraid of doing taking the risk if we can see and can at least show in practical terms that we're confident that this is going to work and give these benefits in the end.
Yeah, so it's important, I think, for everyone here to realize, I think, the impact that Kindred has had on Cockroach Labs. When I first went to Sweden to talk to you guys, geo-partitioning was an idea we had. It was on the drawing board. And from that week I spent in Stockholm talking to Kindred about the problems that they were trying to solve, this thing that was an idea, something of a wild idea, really, actually started to look like a solution that would make a big difference. So that's over the last year, this has become a reality. And I would say that building something like geo-partitioning isn't something that takes a year. Geo-partitioning was something that could be built on the foundation that we'd been creating with Cockroach in a year. So that was enabling. But my question to you is, over that year where we've been developing this feature really with Kindred's use case as a guiding light, sort of a North Star, how's the experience been working with us?
Well, it's been a fantastic journey for us. It's very beneficial. I mean, from many points of view. One is that Cockroach Labs is a phenomenal team of engineers with a lot of experience of building large-scale, complex distributed systems. So we have learned quite a few on the road. So the experience has been, I think, mutually good. We had some interesting use cases that we actually tried out when you first visited us to see, this is our problem, how could we solve it? Because we can see these characteristics and properties in your database solution. And it kind of grew from there as an idea that you presented. And we saw, the more we looked into it, the more we found out that it was quite a perfect match given the highly regulated markets we're operating in, and we want to keep one single coherent platform, operated globally, address high availability, local performance, regulatory compliance, and all of that. So we definitely saw the potential very early on in CockroachDB and saw it as a key enabler for our global expansion.
Great. So Kindred has been a long-time user of Oracle, which is, the big incumbent in our industry, and it's a great product in many ways. There's obviously a huge amount of investment that the whole industry has in tools and knowledge around Oracle, and I'm sure within Kindred. Can you tell us a little bit about how that transition has taken shape and what the sort of key challenges have been?
Yeah, I mean, Oracle is a great database that's been evolving for 40 years or so, so it's a very mature product. We use it quite extensively in our platform, both for our online systems and offline data warehouse systems, for reporting tools and all of that. However, we realized also early on that if we want to gain this business objective of having global scalability, it's not a native and natural thing built into Oracle databases, really. So if we will go continue using Oracle when also operating from multiple active data centers worldwide, we will need to add certain distribution logic to our applications or other proxy layers on top. And we kind of learned through our experience in the past that the complexity in building such solutions doesn't really go away. You need to contain it somewhere. We felt that the best place to contain the complexity of distributing data globally is really in the database layer. That enables us or the developers to really focus on solving business problems instead. So quite early on we said we need to think differently. We need to look at something that natively supports this global distribution of data. And that's why we started with Google Spanner and similar research papers on how could we actually do this. And especially two camps. You either go for some strong consistency solution model. So you take the best of traditional SQL systems, the usability, the performance, easy adoption and so on. And you take the scalability properties, availability properties of NoSQL systems. So you can combine these two which been kind of explained as being very hard and impossible to do in the past, because you either need to shoot one of the camps. You either go this road or that road. But in CockroachDB, we really saw you can actually, when you put your good engineering to it, you can actually solve these problems, which is what Google did initially, which was also an inspiration for CockroachDB. So we felt very confidently we want to go down this track, keep hugging strong consistency still, because we find it does scale if you have the proper technology stack for it.
So a bit of a question about buy-in, and this is sort of related to the question of Oracle or any other incumbent piece of technology that's in anyone's stack. What have been the challenges in getting internal buy-in in a large organization for a new piece of technology, and do you have recommendations for anyone else about how to go about that?
Yeah, introducing new technology always requires that you have some kind of new business problem that doesn't really fit into what you're currently doing. So there's new conditions that comes up, which enables you you have to think, how could you solve this problem, and what are the best options for you? When it comes to buy-in, it's much about allowing people to reflect and make some proper pre-studies and discuss things in open conditions. So buy-in comes if you allow it to take some time, and you present different gaps between how different solutions could look, what are the pros and cons and impacts on what are the kind of the important abilities that you're aiming for. So it's been quite straightforward. As I said, we are an innovative company. We're not afraid to think differently. If we see there's a new problem that needs a new solution, then we're open to trying that out.
Great. So you touched on this briefly already, but it would be great if you could give everyone a description of what your current deployment looks like production-wise, what you think it'll look like in 1 year, and then what you think you expect it to look like in 3 years.
Our current deployment today is that we operate our main platform systems from a single facility located in Malta today for license reasons primarily. It's a highly distributed ecosystem of roughly over 200 plus microservices. So we are already kind of building a highly distributed system. However, the technology selections we are running on today are kind of constrained that you operate the platform within the boundaries of a single data center. And when it comes to disaster recovery and resilience, we have sophisticated backup solutions and all of that set up. But within 1 year's time, what we want to be able to do is to actually take our entire platform ecosystem and deploy it to multiple active data centers, perhaps starting with Australia as a first, and then a second and a third in Europe, and from there on. And that gives us the high availability properties through data domiciliation, through geo-partitioning. We can really get local performance. So we can partition the data both for high performance reasons and availability. In the longer term, in 3 years perspective and so on, we really see that we can drastically reduce our time to market, because when we also look into this, we do a lot more than only CockroachDB. We look into how we can automate things and orchestration tools and basically have push button functionality. So from the time we push a button, we say that it should take 2 or 3 weeks before we are operational at a new geography somewhere for a new market. So it's pretty aggressive capabilities we are looking for, but this is really what gives Kindred, we think, a competitive edge, time to market, keeping a coherent system, our operational costs reduced, and providing the best possible customer experience to any market in the world.
Makes sense. What would be your recommendations to anyone that was evaluating CockroachDB? I mean, you guys have been doing it now for a year plus, so I think you're in a position to say.
My main recommendation would be to definitely try it out, pick some good use case you might have, and do some POC tests, deploy it perhaps to production with some low risk thing until you build up enough confidence and knowledge about how it works. Another advice is that while CockroachDB appears as any regular type of SQL database towards the applications, in terms of guarantees and properties, it's still a distributed database underneath with very different capabilities that it offers for that. So there are far less application level considerations you have to take in using CockroachDB, but you shouldn't underestimate that it's still a distributed system, and if you scale it globally, you need to pay attention to how you should perhaps partition your data and how the replicas, how many the replication factors and all of that. In our case, what we did, we defined a spectrum. So we took the toughest use case that we had, the most transaction-intensive system, did it with 20 million business transactions per day, and at one side of the spectrum, and said that if we can solve the problems that we find in that, or provide the same workload, support the same workload running on CockroachDB, we have solved our most challenging problem. And then we took, on the other side of the spectrum, the simplest use case that we have, only to see how big is the transition effort if we go from a current state of a service running on Oracle to just running on CockroachDB. So we just change the driver and do minor changes in the schema. And this gave us a kind of a spectrum of the effort needed to make transitions. But definitely try it out, test it out. Also, you could look into Jepsen tests by Kyle Kingsbury if you really want to push it to the extreme and cause different simulated failures in your clusters, take down nodes, create partitions, split brain scenarios, and all of that. Just put it to the challenge, and that's what we did in our evaluations, and it turned out to work as we expected quite early on, so it was very impressive.
It's great to hear. So how would you describe the future as you see it for CockroachDB within Kindred? And I'd also be curious about your thoughts on CockroachDB for the larger ecosystem.
For us, we are of course, as I've been describing here, betting quite much on CockroachDB because we believe a lot in the properties, what it enables for us as a business, new type of business capabilities. So today, CockroachDB is starting with focusing on OLTP workloads, and that's primarily what we're going to use it for initially for our 200 plus online type of systems. But as the product matures, we also see use cases to use it for more offline and near-time workloads, perhaps create more read-optimized views of certain data. So change data capture is also an important feature that we've been kind of also trying to push a bit for, because we see that as also as an important enabler. So in the long term, we are going to see more and more usages for CockroachDB. Also given the fact that data privacy is becoming more and more important, the data growth is exponential, and we really need a very scalable data solution for a global data architecture that we're aiming for.
Great. Well, I think we have time. If anyone has questions, either for me or Kai, I'd be happy to take them.
Sure. Thank you. This has been very interesting. Could you describe either the biggest gotcha that you faced in trying to use Cockroach, or the biggest kind of operational disaster that you may have encountered in the process?
I would say the biggest gotcha was really that it was actually a better fit than we initially anticipated a bit. But it really worked very well for us. We know that it's still an early product. It didn't really live up to performance that we wanted initially, but that was also very clearly defined that the primary focus of CockroachDB was initially on resilience and stability, because that's what makes the product, and performance comes later. So we kind of adapted our expectations based on that. Gotchas was really, the main I would say is that we really saw that we expected a transition effort. If you take an ordinary type of microservice with a stateless business component and some kind of relational database, whether it's Oracle, MySQL, Postgres, moving that into CockroachDB was really quite straightforward, given that it piggybacks on Postgres wire protocol. You can just use the Postgres client libraries, client drivers to speak with it, and it provides a very familiar interface to applications. So that would be really one of the gotchas, that it was actually simpler than we anticipated for an average type of component, which doesn't have extreme workloads and so on.
Thank you.
What is the biggest size of table that you're dealing with right now, the partitioned one, in terms of volume of data?
The biggest size of table, I think, Lee, you could perhaps help me there.
Me?
Yeah.
It's in the terabytes, but the thing is, there comes trade-off with, like, when we go into backup and recovery, which has it's also in version 2. We've been testing a lot with that, and then sometimes if you really want a really low recovery time, then you need to manage maybe the size of the data, and then we start to do some other sort of engineering in the background, but we use Cockroach. But yeah, it can be in the terabytes. We've tested up to that. It hasn't been a problem, because at the end of the day, it's just 64 meg ranges that are just distributed through the cluster.
But do you need to partition all your tables?
That's, again, if you want to. In some cases, we have, like, where we need to maintain a global primary key, and again, it wasn't maybe touched on in Nate's presentation, but when you're going to use geo-partitioning, you've got to add the partition key as part of the primary key, and then in doing so, there comes trade-offs with that. But if you really want a global unique key, you can't get away from that. You have to touch a lot of things in the cluster. In some user cases with usernames and registrations, we need a global unique key. But a lot of cases, same with the car demo was quite good, where we have a customer and his transactions, the customer is in Australia, his transactions in Australia, so we just leave them there. So it's that sort of...
And that's for every table that you want to...
Mostly. Then the other thing is, if we had, for example, a 20% user base in Australia and 80% in Europe, then we can just size the clusters number of servers according to... That's another feature that, yeah, you get a lot of other benefits.
Thank you.
How do you do consistent backup across geolocations?
So Cockroach has, always had the ability to read consistently at a time slice in the database. How it provides that is by implementing an MVCC model. So, by default, Cockroach will keep all of the versions of data for 24 hours, and you can configure that by partition, by table, by database. There's a cluster-wide default. So what that means is that you can choose a timestamp, and you can read historically at it, and it's completely consistent. That could be a second in the past. It could be 10 minutes or an hour, a day, or whatever in the past. The backup facility works using that same mechanism. So if you start a backup, now it may have to run for an hour, but it's just going to go further and further back into time. But it's going to keep reading that completely consistent time slice. So when you restore, you get the database as of that database system time. So it doesn't matter where the data is located or whatever. It's it's able to get that exact the complete and exact data at that time slice, and it'll go where it needs to find it as necessary.
Now that you talked about MGCC, do you still have the same bloating issue that we see in Postgres?
We still have the same, sorry,
Bloating issue.
Loading. We can, yes, and we actually, for example, if you rewrite the same key, millions or tens or hundreds of millions of times in a day, which is how long we keep the data, right now that will cause significant performance degradation. I don't know if 2.1 will include significant improvements there. 2.0 had a lot of improvements around that problem. There's a lot more we can do. For example, specific garbage collection policies, especially if you're just going to be doing that, you don't care about the historical data necessarily. There's ways where there's been lots of discussions and sort of pseudo RFCs internally around, well, actually it's external too because it's on the GitHub, but around the idea of, once you get more than, say, 5 or 10 versions, you put that into another column family and the underlying storage engines. So there are ways around it. We have some ways to go before that's just seamless and it's never a problem. But that's also a case where it's, as Kai mentioned, it's important to understand, certainly as a systems architect at that level, what Cockroach is doing under the covers, because you can run into nasty little surprises like that if your application's trying to do something that just isn't fundamentally compatible with the current architecture. Well, guys, this has been great. I think Jessica, is there some wrap up? We good? Yeah. So we'll be around. Thanks everyone for coming, and we'll feel free to ask anyone on the Cockroach team any questions you have. I think everyone would be happy to answer. And of course, feel free to join the GitHub if you aren't already. And there's a newsletter that we send out. Obviously, probably most of you have seen our blog. It's pretty active, and there's pretty great information there. So thanks for coming.